Kia ora 12 MCA and Year 10s and Year 12s and 13s who are redoing AS. This is a request from Zach for a normal distribution problem, and it's a nice example of a couple of the skills that come up all the time. And so I'm going to be going over how we use the normal table, which is up here, with lots of scribbles on it already that will give away the answers, and also how we draw the graphs in order to help us. I'm also going to focus in this video quite hard on making sure that our working is good so that we don't write down illogical things. So in this question, we've got a normal distribution. The times taken to swim 100 metres by members of a large swimming club have a normal distribution, and we're given both the mean and the standard deviation. So that means it's probably going to be a reasonably easy problem. We don't have to work backwards to find either of those out. And the first probability is a straightforward one where we have to find the probability that a randomly chosen club member takes between 56 and 66 seconds. So the first thing to do is to draw a graph of my random variable, which is x. Note that sigma is equal to 5. What I want to do, though, is to turn this random variable x into a standard normal random variable z. Now z is special because the mean is 0 and the standard deviation is 1. So we can mark it on here, and we get between x and z and back again by saying that z is equal to how far I am above the mean divided by the number of standard deviations. Right, so what we're going to do first is we're going to look at 66 up here and 56 and figure out their z values. So the first one is going to be 66 minus 62 divided by 5. So we're 4 units above the mean and the standard deviation is 5. So we're 0.8 standard deviations above the mean. On the other side, we get the second z value is 56 minus 62 over 5, which gives me negative 1.2. And this is what I want to figure out using my tables. The problem is that the tables are written to give me the area below a z value. So when we're doing problems, we have to always think about how we can work with the tables, especially if we're stuck on a desert island and we don't have a normal distribution on our graphics calculator or in the Cambridge exam. So what I need to do here is to find the probability below 0.8, but then to chop off just this little bit in here. So we don't want that area there. So working through what that means is we're going to have phi of 0.8 is going to get me all of that back there. And then the little bit below 1.2 here, so below negative 1.2 is the same as the bit above 1.2. Now, I can't find the bit above 1.2 on my table, but I can find the bit below 1.2. So our problem comes down to this. I'm going to write it up nicely over here. So we've got the probability that x is between 56 and 66, and that's equal to the probability of z being between these two values. And that's equal to phi of 0.8, this minus this bit here, which is 1 minus phi of 1.2. And I can either put the numbers in or clean that up first, but I might as well just simplify it first. So phi of 0.8 plus phi of 1.2 minus 1. So let's quickly go to the normal table and find those numbers. So 0.8 here, 0 here, so 0.7881 for that one, and 0.8849 for the next one. Where are we? Where's it gone? Ah, I've lost the question. Okay, so 0.7881 plus 0.8849, take away 1, gives me 0.673 to 3 significant figures. Let's look at the second part of the question now, which is what we call an inverse normal problem. 13% of the members of the club take more than t minutes to swim 100 metres. Find the value of t. So what am I looking for now? Well, we've got our curve. This is our x. And we want to know what is this number here that gives me 0.13 here. And we're not going to work initially with x. We're going to work with z. And we're going to find the z value. In other words, how many standard deviations above the mean will cut off this probability. If it's 0.13 above, that means I'm looking for 0.87 below. The way to write that up nicely is to say we need phi of z is equal to 0.87. We're looking to find that little z value, and then we'll convert it back to an x value like this, and we'll check our answer and make sure we haven't missed anything. Hint, we have missed something. Right, so going back to the tables, I'm hunting through the big bit of the table, and I'm looking for 0.87, and I want to get as close as I can. So here I've got 0.8686, and here I've got 0.8708. So the number I want, this is at 1.12, and I need to come over here and look at my add factors, and I need to add on 14 little points. So that's going to come from 0.7. So my z value is 1.127. And now I can work out the x value, or the number of seconds that goes with it. So 1.127 equals x minus 62 over 5. That gives me x has to be 5 times 1.127 plus 62, which is 67.6. I think I got 0.64 seconds. Right, and so then we think we're done, right? And we go, oh yeah, I can go on to question 2. But you should always read the question back, because we have missed something here. Well, I've kind of missed it on purpose. We're asked to find the number t, and t is in minutes, not in seconds. So we're going to chuck a stupid mark away if we stop here, because we've just found that, where's it gone? I've lost it, but we've got 67.63 seconds. So we have to turn that into minutes. So divided by 60 gives us 1.13 minutes. So there you go, Zach. That's 2 normal distribution problems done for you. This is the second time I've made this video, because the last time something glitched out with uploading to YouTube. So I'm hoping that this is going to work. If you've got questions on these normal problems, the best thing to do at this stage is a little bit of textbook work, going through some of the basic skills. Thanks for watching, guys, and send in some more requests later on.